All right, last video. I'm going to have you guys label this in class, and I'm going to cut some of these off, but we're going to just look at the respiratory system. As long as you know the major parts, if you took AP Bio and you know the alveoli and you know the bronchus, the bronchioles, the trachea, that kind of stuff, we don't necessarily get this much. Not that this is deep, but we don't necessarily get this far into anatomy and physiology of the respiratory system. Air pollution is a big killer. Certain things are easier to track, the deaths. And I'm not testing you guys on any of these numbers, but it's just more to let you know that people can get sick from the air that they breathe. And in less developed countries, it's more common, obviously. But even in the United States, we see a lot of deaths, a lot of those attributed to smoking. But radon can factor into that as well, and some other things. How do we deal with air pollution? So the United States, the Clean Air Acts started in 1970, just like the EPA and a lot of the major acts. And its whole goal was to try to start to enforce things. So we industrialized, we started polluting, we started destroying a lot of things. And we took a step back and said, okay, we need to fix some of these things. So the EPA, as part of the Clean Air Acts, established the National Ambient Air Quality Standards for our 6 criteria pollutants. And the goal was to bring down the emissions of these particular pollutants, and we've done a pretty good job. And those are still in place. We're going to watch a couple of these videos tomorrow, but EPA's national emission standards for 187, your book says 188, there's currently 187 what are called hazardous air pollutants, and they have emission standards that any company, business, industry has to go by. There's also a toxic release inventory, and what that is that tells you, informs you of the things that are considered toxic, because a lot of things we're not even aware of, we don't know. And not that this covers everything, because it doesn't, but it does have an inventory of things that have been classified as toxic to us. We've seen a decrease in emissions. Less developed countries have a bigger challenge because they're trying to develop, and coal is a big part of it. Plus, a lot of factory jobs, assembly jobs, a lot of places where you might be exposed to a lot of these toxins are in a lot of these less developed countries where they're assembling things because it's cheaper for us to have those things done overseas than here in the United States. Emission trading or cap and trade program. I was just reading something. I want to share it with you guys. I'll share it with you eventually. But cap and trade program or emission trading program, what it is basically every business is given a certain amount or a cap on the emissions that they can produce. Not all companies use their entire cap. So what they can do is they can sell whatever emissions they have left to other companies that know they're going to go over their cap. So what it does is it allows companies who have a tougher time staying within their cap to trade or buy, so to speak, extra space so that they can have more emissions. And companies that have less emissions, they can get a little bit of a cash incentive or trade incentive by selling off their portion of that cap. All right, solutions to air pollution: burn low sulfur coal, remove sulfur from coal, convert coal into liquid or gaseous fuel that's not going to have as many of the pollutants, switch from coal and natural gas, switch from coal to natural gas and renewables. Reduction, disperse emissions, which we kind of do. Smoke, these have to be a certain height. Remove pollutants from the smokestack gases. We'll talk a little bit later about these different types of filtration systems, things called like a cyclone circulator. They have these different things that remove pollutants from there. Tax each unit of pollution produced. Motor vehicle air pollution prevention, walk or bike, use mass transit. Obviously, some places that's more feasible than others. Improve fuel efficiency, get older polluting cars off the road. Clean up, require emission control devices, inspect car exhaust systems twice a year, set strict emission standards. California is one of the most strict when it comes to these things. Reducing indoor air pollution should be a priority. It's a greater threat to human health than outdoor pollution. Same idea, prevent or clean up. Prevention, ban indoor smoking. A lot of places have already done that. Set stricter formaldehyde emissions for carpet, furniture, building materials. Prevent radon infiltration. Use less polluting cleaning agents, paints, other products. Use adjustable fresh air vents for reduction. dilution, circulate air more frequently, circulate a building's air through rooftop greenhouses, use efficient venting systems. And this whole idea is plants will filter out a lot of those things. Ozone layer. Hopefully I can get this in within this video, otherwise we'll have a fourth. But how have we depleted the ozone in the stratosphere, and what can we do to fix it? So there are a lot of chemicals we use, and we'll talk about them coming up here in the notes, that attack the ozone layer in the stratosphere. And it allows more radiation to reach the surface. To reduce it, we have to stop producing those chemicals. And there's been some international treaties, conferences that have aimed to do that and have been pretty successful. So what is the ozone layer? It's concentrated in a layer of the stratosphere about 9 to 18 miles above the surface of the Earth. Ozone is a molecule that contains 3 oxygen atoms as opposed to 2 in the oxygen that we breathe. At any given time, ozone molecules are constantly being formed and destroyed. So you have a constant back and forth of being formed and destroyed, so there's essentially a zero net balance most of the time. This gives you guys, and this is in your notes, I gave you this, so I won't go through all of these, but this just compares oxygen atom, oxygen molecule, which we breathe, and ozone. And this shows a little bit about, how does this form? Okay, so stratospheric ozone production. Ozone is naturally produced by a 2-step reactive process. Ultraviolet radiation breaks apart an oxygen atom to form 2 separate. Those 2 separate bind with an oxygen molecule to form O3. Ozone filters all this UV, UVB in particular. It filters out, protects us. UVA is not something that's quite of an issue to us, but it protects the surface of the Earth, us, and plants. The ozone layer. Ozone is thinning over Antarctica and the Arctic. Not the Antarctica, but Antarctica and the Arctic. And this kind of shows you the total ozone, okay, in these areas. So you can see these are the areas that are most exposed, and it's there's certain seasons of the year where you get the most exposure. These are all what are considered ozone depleting substances, ODS. So you have CFCs, chlorofluorocarbons, you have carbon tetrachloride, you have hydrochlorofluorocarbons, methylchloroform. These are listed in order of how bad or potent they are. Halons are actually the most potent. They do the most damage, or this is the long name, bromofluorocarbons. And then you've got methyl bromide as well. So these are all of the major ozone depleting substances, and they're used for various purposes, and we're going to fill out a little table that will give you guys that information. So here it is right here. We'll fill this out in class, but you guys can pause the video and kind of look these over. But these are the places that these things were used. No longer in the United States are they used. This gives you an idea of how bad or severe these. So CFCs, this is their atmospheric lifetime. This is how long they live in the atmosphere. So things that we did a long time ago are still affecting us. Ozone depletion potential. So the 1 is the highest. So you can see the ozone depletion potential goes down. You can see halons have a huge ozone depletion potential, even more so than CFCs. Couple of things we've done. This is the last slide. Agreements with a prevention approach. The Montreal Protocol. So the Montreal Protocol, there's been a bunch of meetings since then, a bunch of amendments. This is one that I just noted because the idea was to cut emissions of CFCs and halt the production. Since then, they've added in things like some of these other ones like carbon tetrachloride, HCFCs, methylchloroform, halons, methyl bromide. And it's taken longer in less developed countries because these things are cheap. They're easy to use, and in less developed countries, it's a little bit more difficult to phase out. So there's been different amendments to add these different chemicals and to also accelerate the phase out in developed countries as well as the production. Kigali Amendment, I just made a note of because now HCFCs, they really want to phase those out in developing nations as well. So this is just based on where the meeting is, these amendments. And there was a meeting prior to the Montreal Protocol as well, but there's different amendments that have happened over the years. That is the notes. We are finished.